Did you ever walk outside late at night, touch a metal railing, a car roof, or a garden chair, and notice it felt colder than the air around it? That is not your imagination. Some surfaces can lose heat straight into the open sky, and if the night is clear enough, they can become colder than the air itself. For most people, that sounds backwards. We are used to thinking of cooling as something that comes from a machine, a compressor, a fan, a refrigerant line, a giant metal box outside the house pulling thousands of watts every hour just to keep a bedroom comfortable. But above every roof, every yard, and every piece of open land, there is something colder than any freezer you own: outer space. And for a long time, people have known that heat does not only move into air, water, or soil. Heat can also leave as invisible light, infrared radiation. You cannot see it with your eyes, but every warm object is sending it out all the time. Your roof does it. Your driveway does it. Your body does it. Even a glass of water sitting outside at night is releasing heat into the sky. This is the idea behind radiative sky cooling, and the simplest version looks almost too basic to matter. A flat panel, a reflective surface, a clear view of the sky, and a material that can send heat upward through a special window in the atmosphere, where that heat escapes toward the cold of space. No compressor, no refrigerant, no grid power, just a surface giving heat somewhere else to go. That is why people are now looking again at low-cost sky cooling panels made from simple materials like aluminum sheet, reflective films, white coatings, plastic layers, and insulation behind the panel. The exact design matters, but the principle is simple enough to understand in one picture. Your house is hot, the sky is cold, the panel becomes the bridge. At night, this effect is easy to notice. Farmers and gardeners have seen it forever. On clear nights, frost can form even when the air temperature is slightly above freezing, because exposed surfaces radiate heat into the open sky and drop below the surrounding air temperature. That is radiative cooling in action. It is the same reason a car windshield can frost over while the air nearby does not feel quite that cold. The glass is seeing the cold sky and losing heat faster than the air can replace it. Old world builders understood pieces of this without needing modern vocabulary. Open courtyards, flat roofs, water basins, whitewashed walls, and night cooling traditions all used the fact that the sky can pull heat away when the conditions are right. Modern science simply gave the old idea a sharper name. The atmosphere is not equally transparent to all heat. Certain wavelengths of infrared radiation can pass through what scientists call the atmospheric window, often described around the 8 to 13 micrometer range. That means heat emitted in that range has a better chance of escaping upward instead of being trapped close to the ground. A good sky cooling surface tries to do two things. First, it sends out infrared heat strongly in that useful range. Second, it avoids absorbing too much sunlight during the day. That second part is where the real breakthrough came. At night, almost any exposed surface can lose heat to the sky. During the day, the sun is blasting the same surface with energy. If the panel absorbs more sunlight than it releases as infrared heat, it warms up and the cooling effect disappears. So the trick is to build a surface that reflects most sunlight while still releasing heat extremely well. That is why the idea sounds almost like cheating. A panel can sit under the sun, reflect sunlight away, and at the same time radiate its own heat upward into space. Under the right conditions, it can cool below the temperature of the air around it. That does not mean a $22 sheet of aluminum will replace a central air conditioning system by itself. It will not turn a whole house into a refrigerator. And anyone selling it that way is skipping the most important part of the story. Radiative cooling is powerful, but it is also conditional. It works best under clear skies. It works better in dry air than in humid air. Clouds reduce the effect because clouds behave like a warm blanket overhead, absorbing and re-radiating heat back down. Humidity also weakens the atmospheric window because water vapor traps some of the infrared radiation that would otherwise escape. So this is not magic. It is weather-sensitive physics. But that is exactly why it is interesting. Because even with limits, radiative cooling can reduce heat load without using electricity. It can cool a surface. It can help chill water. It can reduce roof temperature. It can support passive cooling systems. It can lower the work an air conditioner has to do. And in an off-grid or money-saving setup, reducing the load is often more important than replacing the whole machine. Think about your AIR conditioner. It is not expensive because it turns on once. It is expensive because it keeps fighting the same heat all day. The roof absorbs heat. The walls absorb heat. The attic stores heat. The room warms up again. The air conditioner starts another cycle. If a passive system can remove some of that heat before the air conditioner has to deal with it, the entire house becomes easier to cool. That is where a sky cooling panel starts to make sense. One idea is to use the panel at night to cool water in a small loop. That water can be stored in an insulated tank and used later to help cool air, cool a small space, or reduce the heat load in a workshop, shed, greenhouse, or off-grid cabin. Another idea is roof cooling. A highly reflective and radiative surface can reduce how much heat a roof holds, which means less heat pushing down into the space below. Another use is food and water. Cooling in simple off-grid systems where even a few degrees matter. These are not flashy uses. They are practical uses. And practical is exactly why ideas like this disappear from mainstream attention. A compressor is easy to sell. A smart thermostat is easy to sell. A high-end HVAC replacement is easy to sell. A passive panel that quietly lowers heat load is harder to turn into a service contract. It does not need a monthly subscription. It does not need refrigerant top-offs. It does not have a dramatic control board to replace. It works silently, when the sky allows it, by using a principle most homeowners were never taught to think about. That is the pattern with so many old and overlooked systems. They do not always replace the modern machine. They make the modern machine less necessary. Shade does that. Ventilation does that. A root cellar does that. A buried cooling loop does that. And a sky cooling panel does that in one of the strangest ways of all. It gives heat a path to space. Once you understand that, cooling starts to look different. Maybe comfort is not only about making cold air. Maybe it is also about giving heat somewhere to leave. That is what your AC is doing, in a complicated way. It pulls heat from inside the house and dumps it outside. A radiative cooling surface does something simpler. It emits heat upward and lets the cold sky act as the sink. The amazing part is that the sky is always there, above the roof, above the barn, above the shed, above the garden. Every clear night, it is available. And the modern world somehow trained people to ignore it. Now, the honest version of this idea is not as wild as the viral version. A small panel will not power your house. It will not eliminate every summer cooling bill. It will not work the same in a cloudy, humid swamp as it does in a dry, open desert. But it can still do something valuable. It can move heat without a compressor. It can cool without fuel. It can help store coolness overnight. It can reduce the load on expensive systems. And it can remind you that not every solution has to come from a utility company, an installer, or a machine with a warranty card. The best off-grid systems are usually not one miracle device. They are layers. A reflective roof, shaded windows, good airflow, a buried cooling loop, thermal mass, night ventilation. And maybe, on top of it all, A simple sky panel sending heat into space while the rest of the neighborhood pays to fight the same heat with electricity. That is the real promise here. Not fantasy. Leverage. Using the free temperature difference between your hot home and the cold sky. Using physics that was always there. Using a surface so simple, most people would walk past it without realizing what it is doing. So the next time you stand outside on a clear night and feel a surface colder than the air, remember what is happening. That object is quietly losing heat to space. No bill, no motor, no fuel. And maybe the most valuable cooling system above your house was never the one plugged into the wall. Maybe it was the sky above it.